Hello guys, welcome to my YouTube channel. In today's video, I'm going to be walking you through the essential Git commands that you need as a developer. Whether you're a data scientist, you're a data engineer, you're a data analyst, at one point in your career, you're going to be requiring some form of Git to manage your versions in your repository. And this video is going to show you some of those commands that are very essential if you must scale in this. I'm going to be heading over to my desk now. And the first I'm going to be talking about is the initial setup. These commands are first things you will need to run when you are setting up your Git on your computer. So for the first time you're going to be using it on your computer, you will need to set up some basic things, and that is why the initial Git command is very important. You will need to configure your identity so Git knows who is making the changes. The first is what you call the Git version. The Git version, this command simply checks that version of Git is installed on your computer. It helps when you are setting up or you're trying to troubleshoot. You could just check what version of Git. Sometimes the version you're using might not be very compatible, or there's some features that might not be in the version you're using. You could just do Git version to check the version of Git you're using. You can set up your name for all repositories by using the second one. So this associates your name with any commit you make across all of your repos. And the third is set up your email for all the Git repos. Same thing as setting up your name. This command, set your email for all feature commits, is important because this is how you will recognize you. That's how Git will recognize you in all of your commit history that you're going to be making. And the final one on the initial setup is coloring. This is optional actually, but some people just like to have that color in their Git output. This makes things a lot easier to read when you're working with logs or diffs. You just want to be able to go through your history. When you're reading them, you want to see that those colors are different, and they actually make it very easy for you to read when you want to. The next part is the repository operations. In this repository operations, these are the commands you will use to create or clone your repositories. And cloning is just like copying repositories. A repository is basically the storage for your project files and version history. You could have the first version, you have the second version. After you make a couple of changes, you have the third version, and you just need to manage this in a consistent repo. To initialize a new Git repo, you use your git init. The git init command creates a new Git repository in a directory you are currently in. What it does is that it initializes Git version control, so any changes you make from this point onward can be tracked. So this helps you to be able to track that. The second is to clone a remote repository. So you have the local repository within your system you're using, and you have the remote repository. So if you're working on an existing project, you can use git clone to download the repository to your local machine. Just provide the URL and Git will make a copy of the repository for you. Now that you have a repository set up, working with files is very essential because these commands allow you to track changes, add files to your commit, and see what's going on in your project. The first is git add files. The git add command adds changes to the specific file. Staging is like preparing your changes for the next commit. You need to do this for Git to track what files are going to be committed. Your staging is like adding. You're trying to tell the Git, this is the file I want to commit, I'm just going to stage it. And that is the adding of the file. So you can say git and add the file that you want. The next is the git add dot. The period there is to say you want to make things very easier for you. Unlike the git add, you mentioned the file you want to add. You could have a couple of files within your folders, within your repos, and you make changes to all of them simultaneously. And you could just say git add all to stage all of the changes in the current directory, instead of adding the files one after the other. So you can't just always be saying, I want to add my main.py and all of these files. You could add all of the files and have them staged. Commit the state changes. Now, this is the one that you're going to be working with almost all the time. You add, and after adding, you commit. Once your files are staged, it's time to commit them using git commit. The M flag allows you to add a message that describes the changes you've made, which is very, very important when you're managing different versions of a particular file. You make changes, it's very, very important you mention what are the changes that I'm doing within this file. The message is important because it helps others and even you in the future understand what this commit does. So the fourth one, alternatively, you could use this fourth one, which is you want to manually state changes every time. So you can say git commit automatically stages all modified files, commit them in one go, but keep in mind that it only works for files that are already being tracked. So you could commit this and put your commit message, and you just want to do it on the go. You could also check the status of all of your operations within Git. You could say the Git status command is your best friend. It shows you what's going on in your working directory, what files have been modified, staged, or untracked. Sometimes it could be lost in a volume of things to do. You just lose track. You don't even know what has been staged, what is pending to be committed. You just want to get the status of everything. And you certainly can use this to perform that operation. And the final one is here. The final one is the git diff. It lets you see exactly what changes have been made between your working directly and the staging area, where you're working and what you've already added. The fourth is branching and merging. Branching and merging is very, very critical because it's a powerful Git feature that allows you to work on different versions of your project simultaneously. The first is the Git branch. The Git branch lists all branches. First, Git branch lets all the branches in your repository. Think of branches like different timelines in your project. You have different timelines, different times that you're working on things, you're adding features. If you want to see all of the branches that you have, you could have different developers working on a particular project. And you could also have different tasks that you're working on in the same project, and you have different branches for the individual tickets that you have on that. You can list all the different branches within that repo, and you can also use the Git branch and to create a new branch. If you want to create a new branch, you use this to create a new one. This is useful when you want to work on a feature. Just to highlight this, when you want to work on a feature or bug fix without affecting the main project. The next is Git checkout. Git checkout, you put the name of the branch. To switch to a particular branch, you use the Git checkout. You'll be working in that branch, and any changes you make will only affect it. It was only going to affect that particular branch. So you want to do something you don't want to affect the main branch, you could use the Git checkout to do all of that within that branch. And when you're done with the changes, you can actually commit that. Alternatively, you can create a branch, so you don't need to every time create a branch, you switch into that branch. No, you could create a branch and check out into that branch automatically. And that is where you use the Git checkout and you put the branch name that you want to check out to. You can create the branch and you switch to that branch at the same time. It's way faster, of course, and it's more efficient for you when you are working on your project. So how do you merge when you are done? You could merge a branch into the current branch that you're working on. There's a particular branch, and so once you're happy with the changes in your branch, you can merge it back into another branch, usually the main one. With Git merge, this combine the changes. So this is also dependent on your organizational policies. Different organizations have different policies they use for managing repos and managing all of this. So you need to understand what is applicable within your industry, within the place you work, and be able to have this implemented. After merging, you can clean up by deleting the branch with Git delete. So that's the final one here. So for the final one, you can actually delete by saying git delete, and you can have that branch removed. So we've talked about managing your own repository, branching and merging and all, doing all of that within your own local, but you have the remote repository. And how do you manage that? The remote repository, they are hosted versions of your Git project, typically on platforms like GitHub, GitLab, or Bitbucket. How do you add a remote repository? With the Git remote add, to connect to your local repository to a remote one, use Git remote add. You usually name the remote origin and then provide the URL. And you just said, I want to add this repo to my local, and you can do that. You can also list all of the remote repositories that you have, and this command lists all of those repositories associated with your project. You often use this to verify where you're pushing or you're pulling code from, and it's good that you're very, very certain of where you are either pushing to or where you are pulling from before you do any of these activities. So you could easily say git remote v, list all the remotes associated with your project. Now let's talk about how you do the pushing to the repository. Pushing is how you send your local changes to a repository. You have the git push. It uploads those changes to a specific branch on the remote repository. So I have two here. The first pushes changes to a remote branch, and the second push a remote branch and track it. So you can actually specify the origin and put the remote branch to say this is where I want it to go, and it's pushed to that particular repository that you have. On the flip side, to pull is fetches and merges changes from the remote repository to your local machine. And you can just pull a particular repository to your machine. So the first one is it fetch and merge changes from the remote repository. You do the git pull and just pulls maybe the main into your branch. And you have the fetch changes from the remote does not merge. So the first, it does the fetch and merge, while the second only fetches but does not merge. You just know how to use each of these and how to work around that. And viewing history, you have sometimes when you need to look back at the project, these commands are great for reviewing past commits and changes. The git log command shows a full history of all the commits in your repository. You can see who made the changes, when, and what they were. What were the changes that they made at this different point. And you can also show commit history in a concise format. If you want a more concise view, you could just say the git log, one line, which displays each commit on a single line. You also have the git show. If you want more details about specific commits, use git show followed by the commit hash. This gives you a breakdown of what was changed in that commit. That is if you want a specific commit and you want information about that specific commit, and you can get all of those information. Because now we've been talking about what changes you can make, how do you make changes, but sometimes you want to undo something. It's just like doing a Control Z. Mistakes happen, and Git gives you several ways to roll back. If you want to unstage a file, you keep changes in working directly, you can use the git reset. The git reset helps you to kind of go back. You just unstage everything. The changes will remain in your working directory. So if you've staged a file by accident, you can unstage it using the git reset. So the changes will remain in your working directory, and you can do that with that. However, for the git reset hard, maybe I should underline this with the red line. You should be very careful with this one, because the git reset hard resets your working directory and staging area to the last commit. This will erase any changes that weren't committed. If there are things that you had not committed, it's just going to erase everything back to the last time you actually did a commit within that directory. So you should be quite careful with the git reset hard compared to the git reset. Now, for the git reset soft, it resets the current branch to the specific commit, keeping changes staged, while the hard is quite different. And you can discard changes in a file and revert to the last commit. You just want to let me go back to the last commit. I don't want to do this anymore. If you want to discard changes in a file and revert to the last committed state, use git checkout file is a simple way to do edits, and you can use this. And for the eighth one is where you now want to work with stashing changes. And I'm going to explain what that means, because sometimes you might be in the middle of something and you need to switch branches without committing. This is where stashing comes in. Git stash, you use that to save uncommitted changes for later use. The command just stashes your uncommitted changes. So you have changes you've not committed, it stashes them so you can work on something else. You can also use the git stash pop, apply changes. So when you're ready to apply the stash changes, you can use git stash pop to bring them back and continue working. You can also list all stash changes, which is very important. You just see everything you've stashed, or you can delete a specific stash entry. You just do the git stash drop and you can drop that. The ninth one is tagging. Finally, we can talk about tagging. Tags are very, very great to mark specific points in your project, like releases. So if you want to create a tag for a specific commit, what this command does is that it creates a tag at the current commit. You might use tags to mark version numbers, for example, and you use the git tag if you want to do that. You can also list all tags, just like we've always talked about, listing of your versions, listing of all the commit, listing of history. You can also list tags. And the git push, you can push tags to your remote repository with git push. This is useful for sharing releases and everything you do there. The git ignore files is just not really a command, is a file where you specify folders to be ignored by git. If you're working with different in every project, there are certain files or directories that you don't want git to track, and this is where the .git ignore file comes in handy. The .git ignore files tells git which files or directories to ignore. This could include temporal files, log files, or configurations that are unique to your development environment and don't need to be shared with others. There could be passwords, there could be some secret, there could be very large files that will just not be able to be committed into a particular directory. You can just ignore them, put them in that folder and put them under the git ignore. And thank you. And I hope this video has been very, very helpful for you to be able to see the different commands you can use to get started with working with Git. Whether you're working with GitHub, Bitbucket, you could actually use all of these commands to get started. I'm going to be leaving a link to the presentation in the description. You could have it, you can always make reference to it at any time. And I hope to see you in my next video. Bye for now.